Okay, so this is the robot that I built. It's my name, and I use this with a Arduino. Originally, I had the Due, but it got fried, so now I'm using the Mega. I'm using two dual motor controllers, and I have a 12 volt, 5 amp hour battery. Um, for the battery, I have two switches. One of them to turn the main power on, which turns the green lights on, and then this one is for the power charger to charge the battery whenever I want. So if I flip that on, the battery starts to get charged through a laptop charger that's plugged in over there. Right now, this is fried. Both these motors are fried. But yeah, what it does is it's a I'm using a PID to with closed loop feedback from the potentiometer on each joint, and I'm only moving the elbow for this project, and I'm comparing a PID controller to just a normal P controller, and I'm comparing each of those with a load, meaning it's holding something heavy, and when it's not holding anything. All right, this is going to be a test going from vertical to horizontal with no load. Has to go from horizontal to vertical with no load. And yeah, let's see. Cool. Here's an example of it going from vertical to horizontal with a load. Here's an example of it going from horizontal to vertical with a load. All right, so this is the data that I collect. I collect the time, the ADC values error, the P value, the D value, U value. This is out of the max U, which is I think 1200. This is the speed out of 255. I think the minimum is 12. This is the actual angle that it's at, and we can see that it approaches 90. And there's zero error, zero, and everything else. This is the angular velocity. Yep.
All right, so now I'm going to go over the results of the data. It looks like the best results that we had were with the P controller going with gravity on the way down to 0. As you can see, like there's no overshoot. Everything approaches 0 just like it should, very smoothly. You can see the angular velocity slowly comes down to 0 and then smooths out really nice. And this is the angle, and this is the angular velocity at the same time. Looking at it with the PD controller, we had a lot more oscillation with the angular velocity. It didn't really smooth out to quite, like, it didn't really hit 0. It kind of had a little bit of error there. So I would say that the P controller is actually better with gravity when there is a load. So now looking at the data with no load, when we don't have a load, we actually get a lot more variation on both the P controller and the PD controller. So it'll arrive at a lot more spread out area. Also, the difference between using a P controller and a PD controller is that the PD controller actually slows it down a little bit. So it'll hit a smaller peak and it'll arrive later, around 6.5 here. Let's see. And this one will get a lot earlier because it doesn't have a D to slow it down. It'll get there before 5.5. So that was interesting.